All right, same morning, wearing the same shirt as the last few lessons, but trying to get these out so I can enjoy the rest of my Friday. So, hope you're all doing well. This should be Monday or Sunday for you guys when you get this. All right, this is lesson 812, and this lesson is about you figuring out the difference between length, area, and volume, and dimensions. So if you look in the vocabulary for the notes, we have 1 dimension, 2 dimensions, and 3 dimensions. And I've talked about this in my class quite a bit. If you think about this, 1 dimension gives you a line. You think about a line. That's 1 dimension is a line. It goes from, so 1. Here, let me make sure I got this right. Okay. 1. Think of a line. Okay. 2 dimensions. Think of area. 3 dimensions. Think of volume. We can also think about this if we're graphing, because when you get into higher sciences, you're gonna use these variables to determine things. Like physics uses it to graph. Let's say and I use this a lot because it's kind of what you learn first in physics. The trajectory of something being tossed in the air or projected in the air, because you graph that in physics, and you need the different dimensions. So you can also think of this as, you got an X and a Y and an X plane, and then you have a Z plane. So you think of the Z plane coming out at you. This is 1, 2, 3 dimensions. Okay, so you think about it. So for 1 dimension, I need to know, what it's going on 1 direction, X. That's a line. That's 1 dimension. 2 dimensions, so if you think 1 dimension, you got length. You can talk about a length. 2 dimension, you got length and width. 3 dimension, length, width, and height. So 1, 2, 3 dimensions, if we think about it. And you can graph it on this, using if you think of Z coming straight out, Y going up and down, and X going this way, we can graph all 3 of those things. We need, for a line, you can do just between point 1, point 2, you can draw a line. It's 1 dimension. 2 dimensions, we need another direction. That's going to give us area. And 3 dimensions is going to give us one more depth to that. So those are our 3 dimensions. So the problems today is you determining, is it area, is it volume, or is it linear? Now, in physics, we have a 4th dimension. Now, does anybody know what that is when you're dealing with things? So if I think about, if I'm going to toss my marker through the air and I throw it, okay, I can, using 3 dimensions, I can figure out where that marker is at any point. So I got my y-axis, my x-axis, and my z-axis. Okay, Z. Okay, I can, if I throw the marker, let's say from here to here, it's going to go like this, over there. So I can figure out, using those 3 points, where that marker is at any given point. And I can mark it. In physics, this is what you do. And I know this is a little advanced, but I always like to give something why we learn something, because where it'll lead to. And, we learn these things because they help us when we get into, real world situations. And we live in a complex world, where we have all specialized jobs. And some people's job is to be physicists or chemists or botanists or surgeons, whatever. But these mathematical formulas lead to bigger things, and you use them. Computer science uses these. You have to understand, kind of these basic mathematical principles because they lead to understanding of deeper concepts. And I just use something simple like throwing a marker through space because think about, if you're an astrophysicist, that's how they figured out how, pretty much a little bit more complicated, but how to get a rocket to the moon. Just figuring out how something was traveling through space and how gravity affected it. So the fourth dimension in this would be time, how something travels through time. But you don't need to worry about it, but I like to, give you a little bit more than you need. So if I wanted to figure out how to throw something through space and where it was going to land, I would need an right-left direction, an up-down direction, and a forward-backward direction. But I also need time because it travels through time. It doesn't just get to point A or point B, it has time. So that's just something a little extra, We're all stuck at home. Why not learn something more? All right, so today, that's all you really need to know. Which one of these are they talking about? Is it a line, an area, or is it volume? So let's just look at, and I want you to make sure you read everything on page 291. Compare length, area, and volume, okay? And it gives you the definition of those things. I also gave you some definitions in your notes, okay? So how much water is in a swimming pool? Well, how many dimensions does a swimming pool have? A swimming pool has a length, right? So if this is my swimming pool, it has a length. It has a width, right? And it has a depth. The pool, unless you have a very, very shallow pool that has just a skim of water, which I wouldn't dive into, you have depth. So this is how many dimensions? You got A, B, and C. That's 1, 2, 3 dimensions. So it's 3 dimensions, so it is volume. So area of a swimming pool is volume. All right. So you're going to have to go through this. They'll ask you questions. It's pretty straightforward. And there's some real world problems on the back that you're going to have to figure out the answers to. And when we meet small group, if you have any questions, I'll help you. Let's do one more example. Okay, I want to tile my kitchen. Okay, is that going to be 2 dimensions, 1 dimension, or 3 dimensions? What am I going to need to know? Well, my kitchen is 15 feet by 12 feet. Okay, that's my kitchen floor. Now, how many dimensions do I have? 1, 2. So it's 2 dimensions, so it's area. Okay, so that's pretty much what we're doing today. It's pretty simple. Good luck, and I will talk to you in the next lesson, which for me will probably be in 5 minutes. All right, bye.